Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And welcome to the session, very unique session, useful session for BARC and HAL aspirants atomic series. Today we will discuss the data structures, most occurring and most important questions. Before we start, I request all of you, whoever have joined the session, to mark your presence in the chat box. Abhishek Panwar, good evening. Join the session quickly and mark your presence, everybody. Also, whoever have joined the session, please do invite your friends through Instagram, Telegram, Facebook, WhatsApp, Twitter. Okay. AG Nishant Raj, good evening. Good evening, Pooja. So before we get in, this is the quick introduction about me. I am Satya, research scholar with all these credentials. Guys, on 5th March, our experts Rakesh Sir and Ashutosh Sir coming to you to give you the preparation strategy for GATE 2023 and 2024 aspirants. Also, when is the right time to start your preparation, and along with the tips and tricks at 8 p.m. on YouTube. So do join the session without fail and get the experts advice for your GATE preparation. Okay. So this is the atomic series complete schedule. Currently we are on this programming data structures part 2, and day after tomorrow Anil sir will take up operating systems most important, most occurring or most expected questions of operating systems, followed by DBMS, discrete maths, and so on. So you can just find the complete schedule of this atomic series and try to attend all the sessions continuously without fail. Okay. So guys, if you want to connect with me, join my Telegram group through which you can connect. You can get your doubts clarified, get the PDF. Okay. Noob Studios, could you please refresh? So everybody, please confirm, am I audible and visible clearly or not? Okay. So let us start with the first question of the day. The postfix expression for an infix expression is what? Solve this and give your answer for the first question of the day. The postfix expression for an infix expression is. Guys, keep liking the session and keep sharing. Okay. A.B. de Villiers says option B. Okay. Nishant Raj says option B. Mhm. Abhishek. Yes, Abhishek, what is your answer? Okay, B. Right. So what is the procedure? Scan the expression from left to right. First, let me draw the stack here. Postfix expression here. First, two left parentheses are scanned, then A, then plus, then B, then right parenthesis. Whenever we get right parenthesis, neglect the parenthesis and pop till the first left parenthesis. Done. Then minus, then C. So C means we will keep in the postfix expression. Then multiplication. Multiplication has more priority than top of the stack. So simply we will push on to the stack. Then we have left parenthesis. Then D. So D, which is an operand, we will keep it on the postfix expression. Then we have division. As the top has left parenthesis, simply push on to the stack. Then E. Then we have right parenthesis. So until left parenthesis pop and neglect the parenthesis. Again we have one more right parenthesis. So until left parenthesis pop. So we will pop star, then minus, neglecting the parenthesis. Then I have plus, then F, and then stack expression is over. So we will empty the stack. So the resultant postfix expression for this expression is AB plus CDE division star minus F plus S. As you all people said, it is option B. Very good. So guys, welcome Anshul sir for this session. Your favorite Anshul sir is here to invite you all, to wish you all very good evening, Anshul sir. Question number 2. The prefix expression for an infix expression is. The prefix expression for an infix expression is. Okay. So Saubhagya Naik Muhammad Saif says option D for the second question. Nishu also says option D. Okay. Noob Studios, might be your internet connection is not proper. So try to refresh. Okay. So what the conversion procedure says? Scan from right to left, follow the same procedure and reverse the result. if this is the stack and we are getting some result, not the post prefix expression. So first, right parenthesis, here right parenthesis is equal to left parenthesis is equal to right parenthesis. So left parenthesis, we have two left parenthesis, then F, then multiplication, then E, then left parenthesis which is treated as right. So until the matching parenthesis we keep popping, then minus, then D, again we have right parenthesis. So until the left parenthesis we will pop, then we have division, then parenthesis followed by C, then plus, and then B, then multiplication. Multiplication has more priority than top of the stack, so we simply push, then A, then parenthesis. So until parenthesis we keep popping, neglect the parenthesis, expression is over. Now we will empty the stack. Now to get the actual required prefix expression, we will reverse the result. So it would be division plus star A, B, C minus D star E, F, which is division plus star A, B, C minus D star E, F. Yes, option D is correct. Got it? Next question. Question number 3. The result after evaluating the postfix expression given is. Solve quickly. It is 5-4. 5-4. Nishant Raj, it is 5 and 4. Okay. Muhammad Saif says 625, option C for question number 3. Okay. What about others? Tushar also says option C. Nishant, option C. Great. Okay, let's look at it. How to evaluate the postfix expression? Scan from left to right. If operand, we push on to the stack. So first 20 is pushed, then 50 is pushed, then multiplication. Okay. So pop, pop, multiply and push back. Then we have 5, 4, again multiplication, pop, pop and push back. Then we have division. So we perform 1000 divided by 20. This is 50. Then we have 2. And again division, we have 50 divided by 2. That is 25. Then again we have 2. Then we have exponentiation. It is not XOR here. It is to the power 25 square. that is 625. Expression is over, so pop the result. So what is the result after evaluating the given expression? 625. Okay, no Saif, it's not like that. So you expect me to shout or be a little louder? Okay. Next, question number 4. A queue is implemented using a non-circular singly linked list. The queue has head pointer, tail pointer as shown in the figure. Let n denote the number of nodes in the queue. So by looking this question, if anyone have attempted GATE exam, you can easily identify it is a previous GATE question. So why I have brought this? Because in the BARC, GATE questions may recur. GATE 1 mark questions are more probable in the BARC exam. So I have kept some previous GATE questions also, just to make you alert about this. So what is the answer for this? Let n denote number of nodes. NQ be implemented by inserting a new node at the head, and DQ implemented by deletion of a node from the tail. So insertion happens from head and deletion happens from tail. Okay. Which of the following is the time complexity of the most time efficient implementation of NQ and DQ respectively for this data structure? So all are telling option B. Yes. See, it is given single linked list. So in the singly linked list, only forward tracing is possible, not backward. So if you want to insert at the head, it is easy. You will be creating a singly linked list, struct SLL new node. You will be creating a singly linked list new node. Now, where head is pointing, there new will be pointing. I mean, new next you can say, okay, or simply new also, okay. And head will be pointing to the new node. So new will be pointing to the earlier first node, and head is pointing to new node. So new node becomes the first node now. That means the element is inserted at head at the beginning. But you want to perform deletion from the tail end. How you can get this tail end? Yes, we have a tail pointer. Directly if I say free tail, the node which is before tail, the last but one node, will still point to the same memory location. Then this becomes a dangling pointer if you don't point it to null. So to point it to null, you should start from the beginning of the node or beginning of the list and traverse all these nodes. So n-1 nodes definitely you have to traverse. So asymptotically, you can say the time complexity for this, that is big O of n-1, that is big O of n. Hence, you can say for insertion, it takes constant time complexity but for deletion it takes linear time complexity. Okay. Next question. Question number 5. The number of labeled binary trees with 4 nodes is. It's a simple formula based question, dear friends. So quickly answer this. Yes. Okay. So fifth question, I can see many people are giving option A. Anu is giving option C. Okay. So labeled binary trees. The number of labeled binary trees with n nodes will be 2n Cn by n plus 1 multiplied by n factorial. If it is unlabeled, it is just a Catalan number, nth Catalan number, that is 2n Cn by n plus 1. Here what is n? N equal to 4. So that is 8C4 divided by 5 multiplied by 4 factorial, that is 8 into 7 into 6 into 5 into 4 factorial divided by 4 into 3 into, okay, let me keep simply 4 factorial, 8 minus 4 factorial multiplied by 4 factorial into 5 whole into 4 factorial. So 4 factorial here I can erase, strike it. Now this is 8 into 7 into 6, 56 into 6, 336. Yes, Saif, Muhammad Saif, yes. Exclusively for BARC aspirants, BYJU'S is planning full-length mock tests. Definitely, they will be available to you very soon. Okay. Now, question number 6. Consider a binary tree with nodes n. Then, which of the below statements is valid? Minimum height possible is log n minus 1 minus 1. Maximum height possible is n plus 1. Maximum height possible is 2 power n minus 1. Minimum height possible is log n plus 1 minus 1. Okay. Which of the below statements is valid? We have total nodes n. So if we have n nodes, then you will get minimum height in perfect binary tree. maximum height in skewed binary tree? So what is that minimum height? That would be log n plus 1 base 2 minus 1. And what would be maximum height? N minus 1. So minimum height is log n minus 1. No, wrong. Maximum height is n plus 1. No, it is n minus 1. Maximum height 2 to the power n minus 1. No. Minimum height log n plus 1 base 2 minus 1. Yes. So option D is the right answer for question number 6. Okay. Next question. Question number 7. The post-order traversal sequence for the BST with pre-order sequence as so and so is dash. We want post-order traversal sequence. It is said it's a BST and pre-order sequence is given. So solve quickly. We know for BST the in order sequence would be in the ascending order. So first we can write these elements in the ascending order. If so, I'll get 5, 10, 12, 15, 16, 17, 19, 20, 27, 32, 34, 37, 40. 3 plus 3, 6 plus 3, 9 plus 4, 13. Yeah, 13 elements. Now, from pre-order or post-order sequence, we can identify parent. It is given pre-order. So, in the pre-order, parent will be always at the beginning. So, 20 will be root. If 20 is root, in the in order, all these elements will be towards left, all these elements would be towards right. Now, in these elements, which is upfront, 10 is upfront. So 10 would be parent. When 10 is parent, 5 will be left of 10. Okay. Now, in this, which is upfront, 15 is upfront. So 15 would be right child of 20. Sorry, 10. When 15 is parent, 12 is towards left of 15 and 16, 17, 19 would be towards right. Now in 16, 17, 19, 17 is upfront. So 17 would be parent, 16 would be towards left, 19 would be towards right. Now In 27 to 40, 32 is there at the beginning, so that would be parent. When 32 is parent, 27 will be left of it, and in the right side we have 34, 37, 40. In that 37 is upfront, so 37 would be the parent, 34 being left child, 40 being right child. So this is the resultant BST. Now we want post order sequence. What is post order? Left, right, parent. So if you go on with that, 5, right is again a subtree, so go with the left. 12, 16, 19, 17, 15, 10, 27, 34, 40, 37, 32, 20. So this would be the post order traversal sequence. 5, 12, 16, 19, 17, 15, 10, 27, 34, 40, 37, 32, 20. That is option A. Yes, I appreciate everybody for giving the right answer for this question. Very good. Next question. If the elements 80, 40, 70, so on to 10 are inserted into an empty BST in the same sequence, then the pre-order sequence of the resultant BST is given as. Solve it quickly and give the answer. We are inserting these elements into BST. So what would be the resultant BSP and what is the pre-order sequence of it? Everybody solve question number 8 and give your answer quickly. Always the first node considered as parent or root node. 40 compared with the root, as it is smaller, it would be left child. 70 compared with 80 compared with 40. 60 compared with 80, 40, 70. 90 will be right to 80. 50 less than 80, greater than 40, less than 70, less than 60. 30 less than 80 and less than 40. 20 less than 80, 40, 30. 100 towards right side of 90. And 10 will be like this. Now we want the pre-order sequence. Pre-order says parent, left, right. So parent is 80. Left is again a subtree, so first parent. Left is again a subtree, so 30, 20, 10. Then right is again a subtree, so first parent, then left, and then 90, 100. So 80, 40, 30, 20, 10, 70, 60, 50, 90, 100. It is option D. Yeah, the answer for question number 8 is also option D. Okay. Next question. Consider a min heap with elements. After inserting elements 20 and 7, the level order sequence would be. It is also a previous gate question, dear friends, and definitely this model question might have come in the BARC exam also earlier. Definitely. And guys, keep liking the session, keep sharing. First insert 15. It's a min heap. So first I am constructing min heap. So this is the min heap given for the given elements. Now 20, initially we insert as right child to 25 to satisfy structuring property, but as it is not satisfying ordering property, we will swap 25 and 20. Then 7, initially we insert as left child to 40 and we do swapping for satisfying ordering property. So this is what the obtained min heap. Now the level order traversal sequence would be 7, 15, 20, 30, 42, 27, 25 and 40. Option D again. Okay. Next question. Question number 10. The second leaf node in min heap after construction with elements inserted in that order is. So we are constructing a min heap by taking elements in this order. After the heap construction is over, what will be the second leaf node? Solve quickly. We want the second leaf node, guys. AG says option B. Okay, look at it. First we insert 10, only one element, so definitely it is a heap. Then 7. As it is a mini heap, we will swap 7, 10. Then 8. then 9. As it is a mini heap, we will swap 9 and 10. Then we have 3. So we will swap 3 and 9. Okay. So let me draw this here. 7, 3, 8, 10, 9. Here again it is not satisfying the ordering property, so 3 and 7 are swapped. Now I am inserting 2. So initially 2 and 8 are swapped. 2 and 3 are also swapped. Then 6. No need to satisfy because it is already satisfied. Then 12, so no change. Then 15, no change. 13, no change. So now what is the second leaf node? So what is the resultant mini heap? 2, 7, 3, 10, 9, 8, 6, 12, 15, 13. Second leaf node. What are leaf nodes here? 8, 6, 12, 15, 13. So this is the second leaf node. 6. Okay. Nishant, Satyam B. Naik. I think these two only have given the right answer. We want leaf node, not the level or at particular level. So it would be definitely Rakhi Gupta mostly will be considered. Okay. Next question, guys. Identify correct statement from below. Every full binary tree is a complete binary tree. Every complete binary tree is not a full binary tree. Every perfect binary tree is not a full binary tree. Every binary heap is a binary search tree. Identify correct statement. So until unless you know the difference and you have the clarity, you cannot give correct answer for this. Yes. Option A. Okay. The right answer is option B. Every full binary tree is complete. I'll draw one full binary tree. Check it. Is it complete or not? It is full binary tree, but not complete binary tree. Full binary tree means either 0 children or 2 children. But it is not complete because before filling B, C got filled. Every complete binary tree is not full. Yeah. Here it is complete but not full because node B is having one child. Full means either 0 or 2 children. One child is not allowed. Every perfect binary tree is not full. No, perfect binary tree means a full binary tree with all the leaves at the same level. Hence, in the definition itself, we have that every perfect binary tree is full binary tree, but it is given it is not full, so it is wrong. Every binary heap is binary search tree. What is binary heap? It may be max or min. The parent will be greater or smaller than all its children, both left and right. But what is BST? Left should be smaller, right should be greater. So every binary heap is binary search tree? No. So only option B is true. Okay. Next question. In the balanced binary tree in the given figure, how many nodes will become unbalanced when a node is inserted as a child of the node G? Solve it quickly and give the answer. Here, first calculate the balance factors. G balance factor is, let me change the color for more visibility. G balance factor is 0, C balance factor 1, B balance factor 1, D is 0, F is 0, E is 1, A is 3 minus 2, 1. So balance factors are in the range -1 to 1, so it is balanced as of now. Now I would like to insert a new node as a child to G. So it can be either left child or right child, right? Suppose I insert as left child. Okay. Now what would be the balance factors of new node would be 0, G would be 1, C would be 2, B would be 2, F and E will not have any change, and A would be 2. So what is critical node whose balance factor is other than -1, 0, 1? So here A, B, C, three critical nodes are there. As left child, if you insert. If you insert as right child, so we have A, B, C, G. If I insert as right child to G, balance factor of new node would be 0, G would be -1, C would be 2, B would be 2 again, D is 0, F is 0, E is 1, and A would be 2. So still the same A, B, C are critical nodes. So how many nodes becomes unbalanced if you insert a new node as a child to G, either left or right, 3 nodes. Okay. Next question. While construction of an AVL tree with elements inserted in the order, the rotations performed is R. So it is a little big question. So try to solve it as early as possible and give your answer, everybody. Question number 13, answer please. If you are constructing an AVL tree with these elements, what rotations we perform? LL, LR, RL, RR, 4 rotations. So do we do LR, LL, RL, LR? So what 2 rotations we do? From the options it is clear that we perform 2 rotations, but what 2 rotations we have to find out. So first I am inserting 45 as it is a single node balanced. 21 it is smaller than 45, so I have inserted it as less, left to 45. Then 30 smaller than 45, greater than 21. So if you see the balance factors, it would be 0, it would be -1, and 45 will have 2. So 45 is critical. So what rotation we do here? LR rotation we do. So when you do LR rotation, 30 becomes parent, 45 would be right, and 21 would be left. So we do definitely LR rotation. So definitely the answer is not B. Then I am inserting 12. If you find the balance factors 0, 1, 0, 1, so it is balanced, no need of rotation. And then I am inserting 30, 30, not 30. What? 15. So if I insert 15, where I insert 15? 15 is okay, let me do here 30, 21, 12. 15 is smaller than 30, smaller than 21, greater than 12. So as a right child to 12 we insert. Now if you look at the balance factors, 21 is critical, 30 is critical. Always we will take from bottom to top the priority. So 21, if you take the critical, then again we perform LR at 21. So when you do LR rotation again, other part of the tree will be unaffected. 15 will be root, 21 would be parent, 21 would be right, 12 would be left of 15. Now we insert 17. Where I insert 17? 17 is bigger than 15 but smaller than 21. So left to 21. Now the balance factors, if you find out, these are 0, -1, 1, 2. So 30 is imbalanced. Why? Again here it is LR. Again it is LR. 30 being the critical node. So what you do when you perform LR? 21 would be the root, 30 and 45 would be right child, 15 and 12 will remain as it is, left child of 17 will be still towards left but as right child to 15. This is how it becomes. Now 27 we will insert, where left to 30, so it is still balanced. 35, where you insert left to 45. So if you find out the balance factors, 0, 0, 0, 0, 0, 1, -1, 2 minus 3 minus 1, still balanced. 47, still balanced. So 33, where you insert 33, as left to 35 you will insert. So 21, 15, 12, 17, 30, 27, 45, 35, 47. We want to insert 33, as left to 35 you insert. Balance factors becomes -2, 1, 1 and -2. So 21 and 30 are being critical. So what we will take as critical to balance? 30. So for 30, 33 is towards right's left. So here what rotation you do? RL rotation. RL rotation you do. So when you do RL rotation at 30, 35 would be parent, 30, 27 would be left to it, 45, 47 would be right to it, 33 would be right child of 30. So the right answer would be 1 and 2, option A. What rotations we are doing? LR and RL. Okay. So this requires some practice, guys. Do practice AVL tree concept, because for gate, yes, we have not got any question on AVL tree in CSE, but Saubhagya, last step means 33 insertion. 33 is smaller than 35, so inserted as left to 33, left to 35. Calculate balance factors. 35 balance factor 1, 45 balance factor 1, 30 balance factor. Left subtree height is 1, right subtree height is 3. So 1 minus 3 minus 2. Similarly, 21 balance factor. Left subtree height is 2, right subtree height is 4. So 2 minus 4 minus 2. Now we have two critical nodes. When you have multiple critical nodes, always from bottom to top you will give priority to balance. So 30 you will consider as the critical node to balance. Now what is the recent insertion? 33. So 33 is towards right left for 30. For the critical node, it is towards right's left. So you do that RL rotation. So when you do RL rotation, here let me write here, after the result I am writing 21, 15, 12, 17, 35 would be parent. 35's right, 30's right would be 30's right, no change. Left will be no change. Now we have 35 left, that is 33. It would be towards left, but as right to 27. So this is how it becomes. Now if you see balance factors, -1, -1, 2 minus 2, 0. Wait a moment. Somewhere I did miss. Sorry, 33 will be like this. Wait. I have done a small mistake here. 30, 27 would be left. 33 would be right to 30. 45, 47 would be like this. Yeah, this one. So now this would be -1, 0, -1. So all balance factors are in the range 0, +1, -1. Hence it is balanced. Okay. So option A is correct. Right. Next question, question number 14. Choose the valid BFS sequence from below. For this graph, find the valid BFS sequence. Quick. Satyam says option D. Okay. So if you look at option A, breadth first. So first all neighbors has to be visited. So if you start with the T neighbors M, R, S. T neighbors M, R, S should be visited, but R is visited, but M is not. So option A wrong. M, R, S is visited. Now M neighbors should be visited in some order. N, O. Here P is visited, but where is N? So it is wrong. And option C, if you start with M neighbors are N, O, T. In some order you can visit them. Okay. Now N neighbor, O already visited. Then T neighbors, R and S should be visited. Yes, they are visited. Then O neighbor, P should be visited, but Q is visited before P. Q is R neighbor, not O neighbor. So it is wrong. Now M, N, T, O, S, R, P, Q. Yep. So this is correct. Option D is correct. Okay. Last question. What does the following function do for a given linked list with first node as head? Given the function, options: prints all the nodes of linked lists, all nodes except first node, alternate nodes, all nodes except last node. Bhumi says option B for the 15th question. Okay, let's take some nodes. 1, 2, 3, 4, 5. Let's say 5 is the last node. From the code, we can understand it is SLL singly linked list. If head next equal to null, is 1 next is null? No. So print head next data. So what gets printed? 2 gets printed. And fun one of head next. So head comes here. Is its next is null? No. So print its next data and move to head. Move on. Is its next is null? No. So print its next data and move on. Is its next null? No. So print its next data and move on. Is its next null? Is 5 next null? Yes. So here it written. So by the time it returns, what we have got? All the nodes of the list except first node. Hence option B is correct. Like this, if you take any example, some nodes, it would be easy to analyze the effect of the code. Okay. So that's all with this programming and data structures. Yesterday we have seen programming questions. Today I have covered data structures questions. I tried to cover all the concepts of data structures: stack, queue, linked list, trees. In the trees, formula based question, traversal based questions. Similarly, binary heap based question, AVL tree based questions. Similarly, for stack, conversion of expressions, evaluation of expression, and queue, linked list. So you also try to revise the data structures, both linear, non-linear. Even we have covered graph sequence question also. So the intention is for you to just give you a quick recall of what concepts we have in the data structures. Yep. Okay, this is the concept, this is the concept, this is the model. So please do revise all the concepts in the same way thoroughly with practice. Definitely you will be succeeding in your exams. Okay. Bhumi, tomorrow will be off. Day after tomorrow, same 6 p.m. Operating systems questions you will be practicing by Anil Prasad sir. Okay. Thank you so much for joining the session, guys. Before you leave, don't forget to like the session. Try to share in your WhatsApp, Telegram, Facebook, Insta, everywhere. And also do subscribe to our channel if you have not subscribed yet. Okay. Thank you so much for joining the session. See you in the next session. Till then, have a great time. Take care. Good night. Bye bye.